Hey there, CS210 students. So this is the second recording for Chapter 6 where we're learning about objects. And in this class, in this recording, we'll learn a little bit more details about some things at a little bit more advanced level. So one thing that newer programmers struggle with is how to create classes to encapsulate the data that they're working with. So the example we start off with here is, suppose we want to create a soccer team. So what are some things that a soccer team has? So a soccer team would have a head coach, would have an assistant coach, and it would have a list of players, right? It would have a team name and so forth. Well, we're going to start out by defining what does the head coach, the assistant coach, even maybe the players, what information do we want to encapsulate about them? So they've made the choice over here, so they're going to create a class called person, and each person is going to have a name, they're going to have an age, and this class diagram here, this is using UML, Unified Modeling Language, and this minus sign means that this is a private field in the class. So we have a field called name, and its data type would be a string. We have a field called age, its data type would be an integer. And then for conciseness, they just simply said we have getters and setters for the name, getters and setters for the age, a print method, and the plus symbol means that this is public. Again, private means it's a minus sign. So once we've defined what the person is, now we can come over to our team, and you can see that they have a head coach object that's of type person. Great. Assistant coach, same thing, it's a person. And then getters and setters, again, for conciseness, just in the same line there. So again, one thing that new programmers struggle with is just simply, what do the objects contain? Keep them simple, and then you can combine them in other objects. And they do give us a concrete example of our person here, concrete implementation of it, and then here's the soccer team header and CPP file. What I want to point out here is in the soccer team header file, we have to have the team person. So we have to bring in team person in here, right? So team person, this was defined first, and then we're going to have references, objects of that type. So we have to bring that in here in the header file. And then in the main implementation, we're going to have references to both the soccer team, you can see it right there, and we're going to have references to a person, so right there it is. So we have to bring in both of those headers here in the main file. So again, when you start thinking about your objects, think about what data they have and logically how the parts get put together. Okay, one big advantage of creating classes this way. So if I go back, a nice thing about having classes, I've got a team person class, I have a soccer team class. These are completely separate entities. And I could potentially test that I create person objects that have all the right data. Likewise, I could test my soccer team. Does it have all the right data? And creating those classes, those small classes, lets us test them. And so here in section 610, we talk about unit tests. And what we want to do is be able to test our code, making sure that it is correct. So the quick example that they have here is we have some stats. We've got two numbers that it's going to contain, and then we're going to calculate the average of those two numbers. So coming down here, we've got the method called getAverage, and right here is its implementation. Okay, so here's the implementation, and this is not correct. This is going to take divide first, then add, when really we need to add these first, then divide. So this should really be wrapped in parentheses right here. But in this real quick little example, they come down here and they check to see our number one. So we're going to set it to be 100 and then check to make sure that we get the value back. We'll set num2 to be 50, check to see that we get it back. Here they're going to check to see if we set num1 to 10 and num2 to 20, that their average should be 15, and if it's not, then it's going to display a failed message, which in this case it would, because we have it incorrect. So they're creating a main method that is testing this just using some simple if statements. Okay, let's go to the next section. So here we talk about what I mentioned in the first recording. How can we create constructors that take information in that we can then initialize our class with? So we started out back in the initial restaurant class that it had a constructor. We were setting the field name, the field rating to just dummy values, but really we should not do this, okay? I'm not a big fan of this in industry. If we're gonna do things like that, that should be only done in rare cases. What we should be doing is we know the name of the restaurant, we have a rating for the restaurant that we provided. So maybe we only know the name. So that would be a case where we might set the rating to a -1. We should know the name of the restaurant, right? We're creating it, so we should know its name. So we create the constructor. It's just a method. Remember, we give it the name of the class and then whatever parameters we want to provide it. And here they are then setting the initial name to the field name, the initial rating to the field rating, and they show two examples. One where this uses the default constructor. So this would have no name, rating would be -1. This one, they are passing in the name and the rating. Keep in mind, this is a function, it's a method, just like all other methods. If you don't put the data in the correct order, if you try to swap and put an int followed by a string, it's going to fail. So make sure that you put the proper data in the right order. So this idea is called overloading the constructors, and you can have as many overloaded constructors as you want, as long as their parameter lists, their data types are different. So if I wanted to, I could have one with just an initial name, and again, I could set the name and then set the initial rating to, -1. C++ does offer the ability to inline default parameter values. So we do that here in the implementation. We have a parameter for the initial name, we have a parameter for the initial rating, and you can see that they are providing those values here. Oh, by the way, just like functions, once I declare something with a default parameter, each parameter after it has to also provide a default value. So maybe I don't do that here and I provide it right here. So that right there, I would probably say, no, don't do this right here. But we could set the initial rating to -1. C++, some versions provide what's called a constructor initializer list, where we have the fields in our class. And when I define the constructor, I set the field 1 value, I set the field 2 value. I don't think you're gaining anything by doing this. It's going to perform the exact same work. I'll be honest, in most production code, they're going to expect to see it like this right here, not in this format here. So it's a nice thing that you can do. I would highly recommend that you just keep it simple. Do it as we've done in, say, Java. So they show an example in the constructor. And again, it's kind of a newer construct. I would avoid it in production code, but you might come across it in some of the Zybook stuff. Okay, so the next thing we're going to do here is look at inside of a class, we have a field called side length. And typically, we have a setter or a parameter name that is the same name as the field. So here we've got a parameter called side length. We have a field called side length. And if I just did this right here, so if I just said side length equals side length, it would be setting the parameter equal to itself. That's not setting the actual data member. So in the case where our parameter is the same name as a field, we use the this keyword. So in C++, we use this and then the arrow operator, and this will assign the value of the parameter side length to the field side length, okay? So again, it's typical that the, again, parameter names match the field names. So they show an example with a setter. The same exact idea is going to work with a constructor, which they show right here. So they're referencing the hours using the this keyword. Again, this would have been hours, this would have been minutes, and you have to use the this keyword in those cases. C++ offers something called operator overloading. The idea here is we can take the standard built-in operators, plus, minus, multiplication, and we can provide our own implementation of those for objects. So keep in mind, typically you're thinking plus, that is going to add two things. It's going to perform mathematical addition or string concatenation. But we might want to take, I'll come down here. So we've got a time, hour, minute class. We might implement a plus operator that handles combining hours and minutes for some particular object. So we can overload the plus operator. So do they have the main implementation? They don't have the main implementation in here. It'd be right here. So down here you can see, well, they got two different objects. When they use the plus operator, then we would have a new time, hour, minute instance that would perform this functionality right here, where it's going to combine the hours, it's going to combine the minutes, and now we have a summed value. So again, C++ offers this. For our cases, we're probably not going to be performing any operator overloading, but make sure that you're familiar with the idea. C++ also lets you overload comparison operators. So for instance, the equality symbol, this one is something that is going to be performed more frequently, where we might have a review object and then a different review object, and we want to compare whether or not they are the same thing. And in order to do that, we define our own criteria of whether or not they're the same. So for reviews, they are simply saying that if the rating and the comments are the exact same, then it's got to be the same object. So again, this one would be potentially added to all of your classes. And you can also overload the less than, greater than. You can overload all of the equality and relational operators. Okay, last thing, in C++, we do have a static keyword, which means variable is going to be allocated only one time, which means all references, all objects are going to reference the exact same memory and therefore share some kind of variable value. So in a class, the static data member is a data member. Again, it's a member of the class instead of a data member of each object. So there's only going to be one reference to it. And to declare something as static, you provide it with the static keyword here. So we have a store class, and a nice instance here of using static is going to be the next ID for a store. So each store has a reference to this, so we can always get what the next one's going to be. And they show right here in the constructor, we're going to take in a name and a type. And then right here, let me back up. Right here, we set the ID to be whatever the next ID is, and then we increment it in the constructor. So it would start out as a 0, so the first store gets an ID of 0. Next time through, it's going to be a 1. So whenever the next store gets created, its ID would be 1, incremented, and so forth. So if you know that you're going to have anything that's shared amongst all objects, then you're going to declare it as static. You can see here that they've really cleaned it up because technically in this implementation where this is public, anywhere inside this code, we could change that value. So they cleaned it up. where they made it a private member variable and then provided a public getter for it. And you can notice that the public getter also had to be static, so you can reference it using store dot get next ID, which they do right here. Okay, a lot of this is good to know things for down the road. Some of it you might be implementing in our next project.